In this video, we'll find the inverse of a matrix and solve a linear system. Here we have example. Let the matrix A equal 1, 2, 3, 4. The first question, find the inverse of A. So here in this question, we want to find A inverse. Question 2, using part 1, solve a linear system AX equal B, where B equal 1, 2. So we want to use the inverse of A, which is here A inverse, to solve this linear system. How to use it to solve a linear system? We have to multiply both sides from the left. We want here A to be disappear. So if we multiply here A inverse and here A inverse, then here A, it will be disappear. So it's like this, A inverse, you multiply here A inverse, so it will be like this. And if you multiply here A inverse, you have to multiply here A inverse, so it will be like this, and multiply by B. This one, it will be identity matrix with size 2 by 2, so here 2, and identity matrix multiply by X, it will be X, so here it will be X equal A inverse B. So if we find the A inverse from this part, you have to multiply by this B, you will get the solution X. That's it. I will illustrate all this in a nice way when I will answer number 2. Now let's erase this. Now I would like to review how to find the inverse and dive in to understand each step. Now let's go up. I will review all of these in a quick way. The steps to find A inverse, you have to find it by either this method or this method. I prefer, if it's 2 by 2 matrix, I prefer to use this method. Now let's focus on method 1. You have to write it in augmented matrix first, then you have to apply RREF to the left side, and of course if you apply RREF to the left side, which is before this line, if you apply RREF to this left side, the operation that you do to the left, you have to apply to the right as well. So if you can transform A to identity by RREF, which means that you use the elementary row operation. There are 3 types of row operation, which are row switching, row addition, row multiplication. So if you can transform A to identity, then you have to the right side A inverse. And of course, if you want to back again, if you want to write here A inverse and here identity, then if you apply RREF and you get identity matrix, then here you have A. The important note, if you can transform A to identity, then A inverse exists. If you cannot transform A to identity, then A inverse does not exist. So it's very simple. So if you can transform A to identity, you will find A inverse. But if you cannot transform A to identity, for example, if you have a 0 row at the bottom, then you have to say A inverse does not exist. And the same thing, if they told you A inverse exists, you have to know you can transform A to identity. If they told you A inverse does not exist, then you have to know that you cannot transform A to identity. That's why I put not equal. The second method, you can also find the inverse of a matrix by finding the determinant and the adjugate, or they called it the adjoint of the matrix. It's easy to figure out if the inverse of a matrix exists if you compute the determinant. Because if you compute the determinant, if you have a 0, then you cannot compute A inverse because it will be here 1 over 0. So that's why here, if the determinant of A equal to 0, A inverse does not exist because it will be here undefined. 1 over 0, it's undefined. So that's why here A inverse does not exist if the determinant of A equal to 0. So you can compute the determinant to check if the matrix has inverse or not. Therefore, no need to do a lot of calculation like here. So here you just compute the determinant. If it's equal to 0, then you will stop and you will say A inverse does not exist. So in this method, you can check if the matrix has inverse or not. In case if the matrix 2 by 2, for example, let's here A equal A, B, C, D, here it's mean any number here, then A inverse has this formula. And you can see here, this represents the determinant of A, and here it represents the adjugate, or they called it adjoint of A. You have to memorize only this one, and then you can find the inverse by compute this and this. And of course, if you here you have 0, then you have to say A inverse does not exist because AD minus BC equal to 0, or you can say the determinant of A equal to 0, therefore A inverse does not exist. I remind you, this one is the same as the determinant of A. In simple way, I wrote it like this. So if you have the determinant not equal to 0, then you have to know A inverse exists. If the determinant of A equal to 0, then A inverse does not exist. As I told you here, you have here if and only if. If they told you A inverse exists, then you have to know the determinant of A not equal to 0. If they told you A inverse does not exist, you have to know that the determinant of A equal to 0. The important note here, if A inverse exists and you have the system AX equal B or AX equal to 0, then you have to know you have a unique solution. So this, they called it non-homogeneous system. This, they called it a homogeneous system because it's here 0. Here it's a 0 vector, but here it's not a 0 vector. So this one, they called it a homogeneous system. So in the homogeneous system, they prefer to call the trivial solution. Why they prefer to call the trivial solution? Because the solution here, x, equal to 0. So that's why they called it a trivial solution rather than a unique solution. They prefer to call it like this. So you have to know if A inverse exists, you have a unique solution for the system, either non-homogeneous system or a homogeneous system. The second important note, if A is not a square matrix, then A inverse does not exist. So immediately you have to say A inverse does not exist if it's not a square matrix. What a square matrix means? It means that the number of rows equal to number of columns of a matrix. Here I put hash, it means number of. So number of rows equal to number of columns. You can see here, number of row equal to number of column, number of row equal to number of column. For example, let's say here you have 1, 1, 3, 3, or let's say here in this matrix you have 1, 2, 3, 0, 0, 1, 2, 3, 4. So here you have 3 rows, 3 columns. The same, the number of rows equal to number of columns. Now let's go a little bit down. Example for how to use A inverse. If A inverse exists, then you can multiply here both sides from the left by A inverse because you want to vanish this A. So if you multiply here A inverse and here you multiply by A inverse, you will have like this, because here A inverse multiplied by B, here A inverse multiplied by B, here it will be A inverse multiplied by A multiplied by X. It will be the same like this. Then you have to know that this equal to identity because A inverse multiplied by A equal to identity. So this we simplify it to be identity, and you know that any matrix multiplied by identity, it will remain the same, so it will not affect anything. So it will be just here x, so just like this, identity multiplied by x, it will be x, and here A inverse B, it will remain the same. So the answer will be x equal A inverse multiplied by B. So the solution, you can find it by this formula. If you have a homogeneous system like here, ax equal to 0, the same as here. You multiply from the left for both sides by A inverse. And you know, here it's not a scalar. It's mean like not number. It's a zero vector. Here it represents a zero vector. And you know that a zero vector multiplied by a matrix, it will be 0. So here that's why it will remain 0 here. So this simplify to be 0. And here it simplify by identity, and also here it's simplified by x, because any matrix multiplied by identity, it will remain the same, so that's why it will remain the same. So x equal to 0. That's it here. Now let's go a little bit down. I wrote this just to connect you if you want to solve a linear system by using the inverse or with the other method. Before, as you know, we solve it like this: A, and you put augmented matrix like this, then you have to apply RREF. Before, we solve it like this. Then if you can transform this to be here identity like this, if you apply RREF, and if you have a solution like this, then you have to say it's a unique solution. And if you have a zero row at the bottom, you have to say infinitely many solution. And if you have a zero row before the line of augmented, and here you have a number, then you have to say this is no solution. And you can obvious see that you can transform A to identity. Since this is, in this case, you can transform A to identity, A inverse exists, because as I told you, if you can transform A to identity, then A inverse exists. So that's why here A inverse exists if you have a unique solution. If you have infinitely many solution, A inverse does not exist, because on the left side of the augmented matrix, it's not equal to identity. The same thing, it's not equal to identity. So that's why here for no solution or infinitely many solution, A inverse does not exist. The same thing with the homogeneous system. Here, if you apply RREF for this augmented, here in this case, you have it like this. Here, if you apply RREF, you will get here identity, then a unique solution. So that's why here A inverse exists, because you can transform A to identity. For infinitely many solution, you cannot transform A to identity, so that's why A inverse does not exist. So this is the connection between using the inverse of a matrix and the other method, like here, Gauss-Jordan elimination or Gaussian elimination, as I have illustrated in many videos before. So that's it here. Now let's solve question number 1 and number 2 as well. Now let's solve number 1. We have tried it in augmented form. So here A, here identity with size 2, because 2 by 2 matrix. So here 2 by 2 matrix. One, two, three, four. Here line of augmented. Then here we have to write identity matrix with size 2 by 2. Now we have to apply RREF. RREF is like a stair or snake game. It's like taking a stair from up to down. So you have to walk until you find a number. So here is the number. Then you have to make it 1. Then if you make it 1, then you have to make the rest of this column 0. We call this here, this one is a leading one or pivot. Then from this pivot or leading one, you have to go one step down. Then you have to go until you find a number. Then if you find the number, then you have to make it 1, and if you make it 1, then you have to make the rest of this column 0. And make sure if you have a 0 row, you have to put it at the bottom. So here you have to put it here. In a simple way, you have to make the left side, which is here, like identity matrix, so you have to make it like this. So this side, you have to make it like this. So here 1, 0, 0, 1. If you cannot transform A this side to identity, therefore you have to say A inverse does not exist. So here we have here A, and here we have identity matrix. So we have to transform this A to identity. So here we have already 1. We have to make this one 0. How to make this one 0? So you have to multiply this row by 3. Then you have to say 3 minus 3. So row 2 minus, it has to be here minus 3 multiplied by this row in row 2. So here we want to make this one 0, so that's why we wrote this. Therefore, this row, it remains the same, so I will speed it up to write this row. Row 2 minus 3, row 1. So 3 minus 3 multiplied by 1, which is 3. 3 minus 3, it will be 0. So here I have to write 0. 4 minus 3 multiplied by 2, which is 4 minus 3 multiplied by 2, which is 6. So the answer it will be negative 2. Zero minus 3 multiplied by 1. 0 minus 3 multiplied by 1, which is 3. 0 minus 3, which is negative 3. So here I have to write negative 3. 1 minus 3 multiplied by 0. 1 minus 3 multiplied by 0, which is 1 minus 0. 3 multiplied by 0, which is 0. 1 minus 0 equal to 1. So here I have to write 1. So here we have a leading 1. Since here we have 2, so it's better to add this row with this row to make this one 0 first, then we will make this one 1. Because at the end we have to make it like this. So this side, it has to be like this. So that's why it's better to make this one 0 than to make this one 1. Because if you, for example, if you make this one first 1, then you have to divide it by negative 2. So if you divide by negative 2, so here it will be 0, and here you have to make it 1, and here, since you divide it by negative 2, then it will be 3 over 2, then here you will get 1 divided by negative 2. Of course, we divide by negative 2 for the whole row, so it will be like this. Then you have to make this one 0, and you have to add these things. I prefer for me to make this one 0 first, then you divide it by 2. Because if you divide the row by a number, it will be a lot of fraction. Of course, you can do it, and to check whether you have the answer like me or not, it has to be the same. So here I want to add row 1 plus row 2 in row 1. So I want to make this one 0 first, then I will make this one 1. So this row remains the same. I will speed it up. And you can see here now it's very simple. So let's add row 1 with row 2. 1 plus 0, which is 1. 2 plus -2, which is 0. 1 plus -3, which is -2. 0 plus 1, which is 1. You can see now it's very simple. Here you have leading one. Now we have to make this one equal to 1. We want to divide by -2 with the whole row. This row remains the same. I will speed it up. 0 multiplied by -half, which is 0. -2 multiplied by -half, which is 1. -3 multiplied by -half, which is like this. Negative with negative, it will disappear, so 3/2. So here I have to write 3/2. 1 multiplied by -half, which is -half. So that's it here. Let's go a little bit down. Therefore, A inverse exists. Why it's exist? Because here you get identity matrix with size 2 by 2, and here you will get A inverse. So since you can transform A to identity, therefore on the right side here you will get the A inverse. And A inverse equal with this -2, 1, 3/2, -half. That's it. Another way to solve 1. As I told you before in the review, A equal, for example, A, B, C, D, A inverse can compute by using this formula, AD minus BC, which is the determinant. Then here you have to swap these two, so DA, and here you have to put negative, and here you have to put negative. So this is the formula, you have to use it to find A inverse. So since we have A equal to 1, 2, 3, 4, then A inverse equal 1 over 1 multiplied by 4 minus 2 multiplied by 3. Then here the matrix here, swap these two elements. So here it will be 4 and here it will be 1. Here it will be -2 and here it will be -3. Equal, and here you know this, it's like 4 minus 6, which is -2. So here we have to write -2. So 1 here, -2, because 4, 1 multiplied by 4, which is 4, minus 2 multiplied by 3, which is 6. 4 minus 6 equal to -2. 4, -2, -3, 1. I prefer to write like this. Then you can insert these negative half in each element. You can distribute it. It will be like this. Negative half multiplied by 4, negative half multiplied by -2, negative half multiplied by -3, negative half multiplied by 1. Here it will be negative, because negative multiplied by positive, it will be negative. Half multiplied by 4, which is 2. Negative with negative, which is positive. Half multiplied by 2, which is 1. Negative with negative, it will be positive. Half multiplied by 3, which is 3 over 2. Negative with positive, which is negative. Half multiplied by 1, which is half. You can see here this A inverse, the same as this. -2, -2, 1, 1, 3 over 2, 3 over 2, -1 over 2, -1 over 2. So we find the A inverse by another method. Therefore, A inverse exists, and A inverse equal -2, 1, 3 over 2, -1 over 2. That's it here. Now we want to solve number 2. Let's go up. So here we have A equal to this, and number 2, we want to solve this system, AX equal B, using the inverse. And how to solve this one is very simple. We have to use the same way as we did it here. So the same as we did it here, we want to solve this AX equal to B. Since AX equal B, then we can multiply both sides from the left by A inverse. Let's change the color. So we want to multiply by A inverse. Here AX equal, and here we want to multiply from the left as well. Here B. Then we know this part, it will be identity. This part, it will be identity. Of course, with size 2, because we have 2 by 2 matrix. Here X, A inverse multiplied by B. Then, and we know any matrix multiplied by identity, it will remain the same. So here X, A inverse B. So we find it like this. So this is the formula, we have to use it. Therefore, X equal A inverse B. We find the A inverse like this. We want to copy this one, -2, 1, 3 over 2, negative 1 over 2. What is B? Let's go up. B is 1, 2. Now let's multiply together. So we have to multiply this by this. So negative 2 multiplied by 1 plus 1 multiplied by 2 equal negative 2 multiplied by 1, which is negative 2, plus, here plus, 1 multiplied by 2, which is 2, negative 2 plus 2 equal to 0. So here I have to write 0. 0. To find this element here, we have to multiply this row by this column. So 3 over 2 multiplied by 1 plus negative half multiplied by 2. 3 over 2 multiplied by 1, which is 3 over 2. Minus with plus, it will be minus. Half multiplied by 2, which is 1. Here, 3 over 2 minus 1, which is half. I will simplify more. 3 over 2 minus 2 over 2. I will simplify more. So 3 minus 2, since the denominator are equal. So I will put it here 2, and we can subtract them like this. Equal. So here 1 over 2. It will be the answer. So here the answer here 1 over 2. So that's it here. Therefore, the linear system AX equal B has a unique solution. X equal x1, x2 equal 0, 1 over 2. That's it. That's it here. Now let's confirm also this solution is indeed the solution for the linear system AX equal B. How to confirm this? To confirm, just in a moment I will illustrate what I mean, how to confirm the solution. To confirm the solution, X is correct. How to confirm the solution X is correct? We have to multiply A multiplied by X, then we have to get B. A, X, A, we know that A equal 1, 2, 3, 4, which is from here, 1, 2, 3, 4. So we have to multiply this A by our solution X, then we have to get this 1, 2. Our A equal 1, 2, 3, 4, and our X equal 0, half. Since here 2 by 2 and here 2 by 1, then we have to get 2 row and 1 column. So here it's look like this, 2 by 1. 1 multiplied by 0, which is 0, plus 2 multiplied by 1 over 2. So it will be 0 plus 1, because 2 multiplied by half, which is 1. 0 plus 1, which is 1. So here I have to write 1. 3 multiplied by 0, which is 0, plus 4 multiplied by half. 0 it will be disappear, so 4 multiplied by half, which is 2. So here I have to write 2. And this one, 1, 2, which is the same as here, as b, 1, 2, which is equal here, equal to b. So we have confirmed that our solution is indeed correct. This is how we confirm the solution is correct. That's it. Here in the future video we will do more video about the inverse of a matrix and its application to solve a linear system. Also we will use the inverse of a matrix to solve more than one system. For example, let's say here you have two systems, ax equal b and ax equal c. So you have two systems and you want to solve it by like this. We will confirm it in some time in the future, and it's very beneficial to find the inverse of a matrix. Feel free to comment below if you have any question or suggestion about this video. So see you in the next video.